How's everyone doing? How's day one been at Java 1? Or rather, evening 1. Sure. Is everyone brain fried at this point? Exhausted and tired after talk after talk? Yeah? You're kind of ready to go and get a beer at this point? But you're here instead? Good. Okay, so I'm going to talk about JSR 347 data grids. I'm actually not going to talk about it. I'm expecting everyone else to talk about it. This is a buff, as I repeat. What I am going to do is I'm going to kind of give you guys a bit of an introduction onto it first, just so that people who are new to it, new to the subject, new to the JSR, so you have a little bit of context to get started. But the bulk of the next 45 minutes is I want everyone to be talking, right? And I will facilitate that. That's what I'm going to be doing. Just to kind of set the frame, is everyone familiar with JSR 347? No? Okay, lots of shaking heads. Is everyone familiar with data grids? Do you know what data grids are? A few more nodding heads, that's a bit better. So that's what I'm going to do. I'm going to give you guys a little bit of context before I get started, right? A little bit about me. I work for JBoss, a division of Red Hat, Red Hat's middleware division. I'm the spec lead in JSR 347. I'm also the expert group on JSR 107. Who's heard of JSR 107? I see a few hands. Not many. Who was here for the keynote yesterday, for the technical keynote? Who saw that? Yeah, so there was a mention of JSR 107 very briefly in the keynote about how it's an important thing in Java EE 7. It is an important thing, so is JSR 347. They're kind of related. I'll talk about how they're related. But essentially, JSR 107 is a temporary caching API for Java. It also applies to distributed caches, again, which is very important for anything that's going to scale, so on and so forth. JSR 347 takes JSR 107 a few more steps further and makes it a data grid, adds a few more aspects to JSR 107 that makes it more tuned for a distributed data structure that's in memory across the grid. A little bit more about me. I'm the founder of Infinispan, which is an open source data grid project by JBoss. It is also a product at Red Hat, which you can buy support on. And there's a picture of my book, which I very recently published. If anybody wants a copy of that, by the way, we are giving away a few copies of that book at the Red Hat stand in the pavilion. You can just go down and some marketing person will talk to you, and then you can get a copy of that. They might scan your badge maybe or something. Right? If you want an autographed copy, if you can find me lurking around, I'll happily sign it for you as well. Okay, so jumping right into things, what are data grids? Data grids essentially are an evolution of distributed caches. The whole concept of taking an in-memory cache of caching objects. We know that this is a fairly common pattern to boost performance, right? Everyone's familiar with this, right? Nods, lots of nods in the audience. Good. You guys know about it, right? A fairly common expensive data store, whether it's a database or a web service or expensive calculation. A very good way to boost performance. You stick a cache in front of it, makes things a lot faster for reads. Now, if your application itself is distributed, a single cache is not that good. You need a distributed cache, a cache that is cluster aware, a cache that knows that there are other servers in your cluster that might change your data, so you might need to invalidate your local cache and things like that. So it's a little bit more complicated than a standalone cache. It's a distributed cache. Now, it's a well-known pattern, like I said. It's proven. It's proven to improve performance and scalability. People use it in front of a database all the time. I'm sure you guys are familiar with this, right? You've all used a distributed cache in some way in front of a database or something expensive, and it is a good thing. It's also, because it's clustered by nature, you get a few other things for free as well. Things like high availability. If a single cache was to go down, if a single server was to fail, your application does not go down because it is distributed by nature. Your data is distributed by nature. You get high availability more or less for free, right? You also get scalability for free because it is distributed. Again, you have the ability to add more servers to increase capacity or increase transactional throughput and things like that. So lots of good things that you get for free. So that's what a data grid is. Very little bit about Infinispan. It is an open source data grid. That's my project. Again, like any other data grid, it is a proven technique to improve performance when you have a bottleneck like a database or an expensive data store. But what we've also seen more recently is people have also used Infinispan as a NoSQL database as well, as a key value store, without a database behind it or without some sort of slow data store behind it, and just purely keeping things in memory, maybe optionally writing through to disk or something for persistence if you want to survive restarts and things like that. But primarily your main data store is in memory, and that's been a very interesting phenomenon that we've seen happen in recent times. So Infinispan is a fairly mature project at this stage. It's been around for a few years. It's got a very active community, both of developers and end users, contributors, people who are extending it and building other platforms and products, some internal, some embedded, all sorts of things with it, as well as people just using it like normal users would. So there's a lot of stuff going on there. It's an interesting community to be a part of. In terms of standards, so far we've talked about two things. JSR 107, I mentioned that very briefly earlier. That's the temporary caching API for Java. And I'm on the expert group for JSR 107. JSR 107 is in an interesting state at the moment. It is almost complete. Now, it's a very old JSR. It's been around for a long time. You can tell by the number. It is finally very close to completion. It's going to be a part of Java EE 7, as was mentioned in the keynote yesterday, and Infinispan is a part of that. JSR 347 takes that a little bit further. Now, just to give you guys a very brief overview of 107. 107 focuses on temporary caching, right? It's got a very simple API of puts and removes and expiry and a few very simple things like that. JSR 107 also supports things like writing through and persisting to disk and reading from disk again and all of that in a very standard platform-independent way. So it does not matter which vendor's product you're using, it'll just work. You have a standard API. Now, one of the things with 107, though, is 107 does not particularly define anything to do with distribution, right? 107 is designed to work with a standalone single VM cache as well as a distributed cache, which means that there's nothing special about it when it comes to a distributed clustered system. Also, 107 defines a lot of other optional features like transactions and things like that that you do not have to implement. And this is where JSR 347 is a little bit different. 347 actually extends 107. It starts with 107, adds a few more things to it, and the few more things to it is what I want to discuss today with everybody here, where I want to get input from everyone, what they feel is useful, what they feel is not, what should these APIs look like. Like I said, this is going to be an interactive session. I'm going to stop talking very soon, and I want everyone here to start talking, right? But before we do that, I'm going to talk a little bit about NoSQL as well. The reason why I want to talk about NoSQL is because there is an overlap between NoSQL and data grids, and I want to kind of, just express my ideas around that, make sure everyone's kind of on the same page here before we start trying to design an API for a data grid, right? So firstly, what is NoSQL? I mean, I tend to look at NoSQL as an evolution of data storage in general. Not that long ago, we had relational databases. We still have relational databases. One of the reasons why relational databases came about, right, was because disk storage is very expensive, right? I'm sure we all remember that time where just trying to get a few hundred megs on a PC was really, really expensive, right? It was like that. And a part of the reason why database or the relational model was invented, it's not the only reason, a part of the reason why it was invented was to save space. Quite simple. Space was expensive. You could not get the 100 gig drives that you can get today and put them in your laptop. You couldn't do that. I mean, it was very, very expensive to have space, and the relational model was built to optimize for that, to save space. Right? Networks were also slow, so you couldn't cluster machines easily and get a lot of space in a cluster. So again, you had to optimize for that. Who remembers COD's normal forms? Second normal form, third normal form. People remember it, right? Who actually uses it today? I'm sure people do, but you kind of rethink that a little bit, isn't it? I mean, it's like, is that really that important anymore? I mean, yes, consistency is important, but it does not matter if you denormalize your data. If it means that you're going to get faster and you can scale out better, it's fine to denormalize your data. Now, once upon a time, you could not do that. You wouldn't dare dream of denormalizing your data. I mean, that just takes so much space. Really, and it's expensive to do that. I mean, today things are different. Like I said, disks are cheap, as we all know. Even memory is cheap. I mean, you can still put your entire database in memory. Why bother touching disk at all, right? So the world has changed, and high availability is much more important now than saving space, partly because of cloud, partly because of demand from users, everything from a mobile, always-on world where everyone is always interacting with most systems. You can't really have downtime. You have to have high availability, so which means your systems have to be distributed at this point. And suddenly you have to rethink the way you store data. You can't have a single database anymore. You have to make sure it's sharded and distributed or something to cope with that. The other interesting aspect that kind of comes out of this is the relational model. It's not something we really liked, right? I mean, it kind of worked. We kind of had to deal with it. But let's face it. I mean, everyone here is a Java programmer, right? More or less, right? So we like object-oriented programming. Yeah, that doesn't quite fit in tables, and tables are kind of, it's a weird mix. That's why Hibernate exists. Hibernate's the world's biggest hack, right? I mean, it is. It's a very useful hack. It's a very popular project, and it works really well, but it is a hack to make an object model fit in a database, in a relational database. We've got to kind of, we have a good chance right now to fix that, to kind of, actually make a data store that works with our programming model. So why not look at that as well? So this is kind of where NoSQL comes in. This is like the whole history of NoSQL. Most NoSQL databases out there, most NoSQL engines out there are designed with horizontal scalability in mind. It means that you can actually scale out using cheap commodity hardware. You don't need to buy big, expensive, specialized servers. I'm thinking Oracle Exadata and things like that here. Or you can actually just buy cheap Dell machines and cluster them together and have the same capacity and the same performance. Actually, a lot more so, because you can scale even wider than you can vertically. So, two things: you scale capacity as well as performance. Two very important aspects. When I say performance, I'm talking about servers, your entire data storage cluster being able to handle throughput, transactions per second. And the other aspect is capacity, to store more and more data, terabytes and petabytes of data, right? Highly available, again, like I said, it's very important, as we have seen with cloud and most business demands today. A lot of NoSQL engines support that. A lot of them are distributed, so that really helps as well. And of course, the whole flexibility of schema. Now, this has been a bit of a debated point. A lot of people tend to use NoSQL because of flexible schema. Now, why is flexible schema such an interesting thing? Well, I think it's interesting because if you look at the relational model and relational databases, right? How do you build an application? You first start thinking about your data model. What are you going to store? What's it going to look like, right? And then you start designing table structures and relationships between them, and then you build your application on top of that, right? Now, with a lot of what's happening in the world today, with social networks, mobile phones generating data all the time, pushing all sorts of stuff, you want to capture all this data. You don't still know how you're going to use it. You've not decided yet how you're going to use all this data. You want to capture it. So now, if you've not decided how you're going to use it, how are you going to design a table structure for it? Well, I don't know. I can just store it all as a blob, I guess. But that's kind of hacky again, isn't it? So this is where soft schemas become interesting as well. I've seen a lot of people turn to using document stores, for example, like CouchDB, where you end up having a very soft schema around your data. And you can change that over time while you're capturing data, and you're not losing data at any given point. You can decide what you want to do with it later. You can still figure things out on the go. And soft schemas it's an interesting two-edged sword, because it means you have to do a lot of validation in your application and a lot of translations in your application as well. But at least it means that your data can be flexible. You don't have to think about what you want to do up front, right? So all that was about NoSQL. Now let's have a quick look at the overlaps between data grids and NoSQL. At least in my opinion, most data grids I feel are in memory. Right? They are in memory. They're accessed from your Java virtual machine. They're not accessed over a socket or anything else. And they're usually optimized for fast, low latency access of data. Hence the whole thing of the data structures being in memory. You optionally write through to disk, so you have some form of persistence, some form of permanence of your data. Whereas NoSQL tends to be, a lot of the NoSQL engines out there tend to start from the other extreme, if you will. They tend to be primarily accessed remotely over a socket, a bit like a database, a bit like a JDBC connection. They tend to be optimized for large volume rather than speed, a bit like Hadoop or Cassandra, where you are talking about storing lots and lots of data as opposed to fast data. This is where the difference between big data and fast data sort of comes in as well. And also NoSQL tends to be primarily focused on storing things on disk, optionally caching things in memory as well. So there's a lot of overlaps there that you can see. And this is where I want to open the floor to discussion. I'm sure people in the room here have played around with lots of different NoSQL engines, right? Hands up who have. Who's actually put them in production? Who's actually running them in production? A few hands up as well, right? What about data grids? Who's actually used data grids in production? Again, a few hands. So this should be an interesting discussion here. I want to start talking about APIs for JSR 347. So I want to standardize the way data grids look and feel and the way you interact with them. And just a few pointers over here, just kind of maybe a few points, food for thought really, to start discussing things like eventual consistency, very popular in NoSQL engines. Eventual consistency will require a specific API. How does an application deal with that? How does an application say, do a get and then get multiple versions of something? How does it deal with versions, version conflicts? How does it deal with healing? So those APIs we can talk about. The other thing is an asynchronous API, again, which I think is interesting. Because you know that your grid is distributed, you should be able to do things in an asynchronous manner. You don't necessarily always want to, say, do a put or a get in the same thread as your application. You might be able to get a future back on that and work with that. Similarly, MapReduce. How does MapReduce work? Again, there are lots of MapReduce APIs out there. Hadoop does MapReduce. Cassandra does it. So, yeah, open the floor. Discussions. Come on. There's a hand up there. Unfortunately, there are no roaming microphones here, so I'll repeat your question and go. Previous slide, sure. That one? Yeah. Well, even with a cluster grid, you're primarily in VM because it's mostly peer-to-peer, right? So you're talking to a peer which is in the same VM as yours.
It's kind of funny. You're still accessing different from one VM. You're accessing another VM, also with a different machine. So you're still going over.
Yes, you are.
Right.
But your interaction is with something in the same VM, or from an application's perspective.
So is with NoSQL. You have a client that connects using a socket to a remote database, right? I mean, there is no really.
It's fair enough.
Difference, right?
And maybe I can strike that point off then.
The other stuff is fine.
I mean, this is just points for discussion, really. It's nothing more than that. So.
I think the key point is in a data grid, you expect the data to be in memory when you go and get it. Whereas in a NoSQL store, you're more likely to expect it from disk.
Yeah.
It's low latency access to data. Assuming you network.
I think that there is more to it than that. I think that the main differentiator for me, when I look at data grid, is that you can actually do processing in the grid.
Yeah.
You can do a lot of things on the data, operations on the data in the grid. It's not just how fast you can access. It's not just cache. Right. So it's really about processing the objects that you have in the grid versus getting and putting objects.
So that's an interesting point that you make, because a lot of people would say that that's exactly what Hadoop does, and Hadoop is not in memory.
Which is fine.
Right. I mean, yeah, sorry. Yes, of course. I mean, this is not necessarily a clear line that's drawn here. These are just a few very vague points. Like I said, Infinispan as well does MapReduce in memory. A lot of projects do that, and the lines do start to blur at some point. Infinispan, for example, can be used both in VM as well as over a socket as well as a remote grid. So, I mean, the lines do start to blur. This is just like some very generalized things that I've seen, and just opens up for discussion, really. Yes.
We move up there because it can become distributed and faster we can do these things.
Yeah, no, I completely agree, and that's very interesting. But at the same time, memory is getting bigger, but data volumes are getting even bigger on the flip side. So I think there is room for both, for sure. And I've seen this a lot with Infinispan, where a lot of people try and put everything in memory, and that's absolutely fine for certain applications. If you are only dealing with a few hundred gigs of stuff, that's cool. The moment you're talking about petabytes of data, memory's not that cheap. And at that point, you really do want to spool off onto disk. So, you know.
So what about like things like Fusion I/O with SSDs?
Well, yeah, I mean that's definitely a very valid approach as well. SSDs effectively act as you know, as far as the operating system and upwards is concerned, it's opaque. It's just a disk. It's just a very fast disk.
Very fast.
Yeah.
So then at this point,
Yeah.
with memory fast
SSDs are still, I mean, I don't know, what's the metric? A normal disk is 1,000 times slower than memory, and an SSD is only 10 times slower than memory, but it still is 10 times slower than memory. So, yeah.
Do you have any thoughts around heterogeneous environments where there could be different versions of the applications trying to use the same cache that don't necessarily have the same object model or version of the object model? So, I mean, how do you deal with something like that with either a fast-moving schema or, you know, that system?
So there are several ways to do that. One of them reminds me of Corba, where you actually ship the object definition with the data itself. That's what Google's protocol buffers do. That's essentially what Google does for a lot of their internal data storage on Bigtable, where everything really is using protocol buffers, where you are shipping the object definition with your data. With a lot of data grids, I know that your actual marshalling layer, it is pluggable, so you can pick and choose what sort of marshaller you use, and you can actually use protocol buffers in many cases as well directly. So that is one way to do it. But there's a cost associated with that, because protocol buffers are not cheap. They're not cheap to actually serialize and deserialize. It's a complete pain to actually have, you know, your protocol buffers compiled in your application. It's also a space hog. It takes up a lot more extra space as well. But those are some of the trade-offs you have. The other way to do it is to roll your own. I mean, it's perfectly fine to say you just want to have everything as a JSON object and then decide which bits you need and don't need and what changes. But again, that's got its own drawbacks as well. Well, effectively, what that is something very similar to protocol buffers. It's just their own proprietary form of protocol buffers. It's got the same costs associated with it.
It doesn't have the same cost, and it doesn't have the same requirement to have external mappings, right? You write your own serialization code, or you can have serialization code generated actually as well. So, but it does support evolution
Of the model,
so you
yeah.
can have new version of the classes in your cluster, in your grid, and you have clients with multiple different versions, older versions, and still not lose data as you go between versions. So it's extremely important in the large data grid deployments, because you cannot upgrade. I mean, we have data grid and you have multiple client applications, you cannot upgrade everything at the same time.
Yeah, and the whole point of a data grid is to be highly available as well, so you can't shut it down and change it.
The other point there is that if your grid is aware of your serialization, then you can do operations basically selecting like an index type thing.
Yes.
You select a number of records. If you use something like protocol buffers, unless you build something else on top of it, you don't get that feature.
Yeah. But again, that's an implementation detail. I don't see how that really fits in a standard, though.
Again, different grids will implement things differently. What I'm actually interested in, well, I guess the purpose of this whole session is, you said we're going to show us proposed JSR 347 APIs.
Well, I wasn't really going to show any APIs because there aren't any at this stage. I was just discussing some ideas. What it effectively is almost all the major data grid vendors already do all the things I'm proposing in 347. They all do some form of querying. They all, let's go to the next slide. They all do some sort of asynchronous work, some sort of map reduce or distributed code execution, some form of querying, some control over co-location as to where your data is located. The only difference is they all do it in a proprietary manner. And this discussion is, again, which of these can and should we standardize on, regardless of what it looks like, firstly, and which of them are better left to just being proprietary extensions.
So what are the top contenders, who are trying to get their proprietary solution turned into the standard? Infinispan is one. Who are the other?
There are a couple of NoSQL vendors in the expert group at the moment who are interested. So you've got, there are people related to Cassandra, there are people related to MongoDB who are interested. On the more data grid side of things, there are folks from GridGain, from EHCache, from Coherence, from Gemfire. Sorry, not Gemfire, Gigaspaces, who are interested as well. So, yeah, these are the conversations we've been having on the spec in the community, and of course, lots of independent people as well. And I think that's really important because I don't want this to be a vendor-driven spec. I mean, I've been on vendor-driven specs before, and it does not really serve the purpose of what people really use, what actual users want. I want this to be quite heavily influenced by users as well.
So obviously you do key value lookup, but what are the if you're saying that you don't want to be involved in serialization, what other mechanisms can you use querying? If you have some concepts of indexing as part of the spec, then you can obviously do an index look.
Absolutely. I think that's a very, very important part.
Do you need to have indexing as part of the spec in order to support queries, right?
No, the actual implementation details is a different thing, whether it's actually indexed or whether it might even break out into a MapReduce job or something like that if it wants to. But the point is that what you're expressing is something that is like, I don't have the keys of what I'm looking for, but I'm looking for these characteristics in some piece of data, go and find it for me. Now, naturally, that sounds like an index-based search to me. It may not necessarily be an index-based search in the way it's implemented, right? So,
It's a setup.
yeah. Sorry, there's a question up there. Sorry, could you speak up a little bit? I can't quite hear you up here.
Saying that for me it looks like the lines between database and database become vague because it looks to me like if you are going to define this API, it's almost an API of the database. It's maybe not a SQL. So let's talk about NoSQL database, but it's the same thing.
Yeah.
The API might be similar because what you're trying to get is get the data out of something, right? But there are some additional things you also want to be able to process data in the grid, right? And the point is, it's not about the API as much as about what data grid represents, and it solves a problem the database is not very good at solving, which is scale out, right? So the API, you still have data, you still want to be able to access the data, but underneath it's very different beast. Which NoSQL database? There is no standard there.
Yeah.
Every database is different, right? Which NoSQL database are we talking about?
So if you are defining this API, it doesn't matter what it might be persistent in some way. This is it. So you won't be able to say any more data grid or NoSQL database.
Yeah, I mean, this is why I said there are lots of overlaps, and I think the overlaps are going to get more and more so as time progresses.
Well, I agree with you, and this actually my interest in this session was from your blog entry about it, where you said that we would discuss the convergence and divergence of
Yes.
NoSQL and data grid. And if you go back to your previous slide, this is a list of divergent points.
Mhm.
So I'm interested in
And convergent points as well.
What are the-
I mean, look at the last ones over there. They actually make things look very, very similar. If I say that a data grid is primarily in memory and optionally writes stuff to disk,
So this,
while a
this is
NoSQL.
the question I have for this room is, must a data management technology implement persistence to be regarded as a NoSQL technology?
What do people think?
Do you call Infinispan a NoSQL technology?
I do.
Does it implement persistence?
Yes, it does.
How?
Various ways. It's a pluggable persistence engine. You can pick and choose.
Cache stores, cache loaders.
So it's not the same persistence implementation as Gemfire's say.
I'm not familiar with Gemfire, yeah.
It's not built-in persistence mechanism.
No, it's a pluggable thing that we, we've shipped with a couple of our own implementations, but there are a few different things.
Sure, you should have the persistence dispatch. When something goes down and you want to bring it up, then you want to again run all those videos or whatever you're trying to do and push it this much into.
Well, it depends. I mean, I've seen a lot of people run things like that where when you bring something up, it just basically gets a copy of data from its neighbors, from its neighboring nodes, if you have big enough a cluster.
It depends how much of data you're going to load and how much
Right.
time you want to wait.
Absolutely, absolutely.
What if there are no neighboring nodes? It's a cold
If it's a
start.
cold start, yeah, in that case you do want to rely on persisting to disk rather than generating everything again from scratch or whatever.
But again, with persistence, especially with the clustering, it adds more complexity of what has newly come in and all those things you have to refresh.
Yeah, but versioning takes care of that. You can do that with if you version your data.
So you said that both Cassandra and MongoDB are part of the expert group that are looking at this.
Well, the expert group's actually is just pretty much just forming. I mean, they've all expressed interest in it. They've all started discussing it.
So are they discussing extending their existing products to support this standard?
In the case of MongoDB, for example, what they're talking about is purely their client library, the Java client library, being compliant with this API. So, yeah. I mean, they're not a Java engine, as you know. It's
Well, I mean, it just seems to me that, just on the topic of convergence, that if the API is as generic as it sounds like it's talking about being, that it's irrelevant whether it's being stored in memory primarily or stored on disk
Yeah.
primarily. That you pick which technology you want purely for what performance or what.
exactly for whatever characteristics you expect out of it.
But it doesn't matter which way as far as the standard.
Yeah, precisely. Which is why, like I said, there is interest from several NoSQL engines.
So why not SQL on it?
Why not SQL on top of this?
Yeah. So in the sense, like we are talking about most of I saw one interesting point in the next slide. That's querying.
Mhm.
So whether querying, why not the querying can be as a SQL? Because that solves a lot of other problems on the
Portability?
portability and a lot of other applications.
There are many reasons for that. There's a lot of discussion going on about. There has been a lot of discussion in the past as well about this. One of the biggest problems with actually implementing SQL on top of a NoSQL, I mean, it's not just data grid, it's any NoSQL engine, is the way you actually store data. You don't have a relational model underneath, right? Now you can hack SQL and translate that into something like that, but it'll be very, very inefficient. I mean, if it's a very simple query, yeah, it's not a big deal. You can do it very easily. If it's even a slightly complicated query, it becomes very inefficient, especially when you're talking about joins, about table joins, when things are distributed across different nodes. You need to pull back a lot of data into a single node and do matches. But the worst thing is you actually don't take advantage of the actual storage engine's capabilities. So let's just say that, are you familiar with graph databases? With things like Neo4j. Neo4j, for example, is it's an open source graph database, very, very useful for certain types of data and certain types of relationships. You try and implement SQL on top of that, and you are, not only is it inefficient to do anything, you're completely losing the benefit of a graph database to be able to traverse node from node to node and link data together.
The reason is like we already have something which is similar to that is the map reduce, right? You are trying to do similar stuff there. Instead of having a SQL, you are trying to do the more programmatic way of.
Well, MapReduce and SQL are completely different things, though.
No, what I'm saying is you are trying to replicate certain scenarios with MapReduce, right? You are trying to collect certain data and then flush it out and then reduce it whatever you want. You can do that similarly on SQL also, right? So it's like in certain scenarios, I'm not saying all the scenarios.
Well, like I said, when you can do a lot of simple queries easily enough. The moment you go beyond a certain threshold of complexity, it starts to break
while
down.
you are doing the map reduce, either way you are bringing out a lot of data between different missions and then you are trying to bring it at one point and then you are trying to reduce it, right? Or maybe you're pushing.
No, the reduce happens remotely as well. So you only get very, very tiny subsets coming back,
So
ideally.
That's what I'm going for. Because in case of SQL also, you can push the conditions into those nodes. Like And then you can
But
reduce
what are you querying on, right? I mean, SQL is designed to query on relational model, right? In a grid, you typically have object graphs stored in some kind of a memory structure, typically key value store, right? And you can query on elements that are deep within the graph, and you query across many machines. You don't really have those relationships that you have with SQL good for. So yes, you can have something similar to where clause, and I'm not sure about the other products, but Coherence does have it. So you can basically have a SQL where clause that gets translated into filter, and you can query within the grid. And you can only query on one cache. You cannot do joins because joins are extremely expensive because again, everything is distributed across many machines. So there are some limitations on what you can do.
And you can't just push them out to individual nodes.
Is it SQL-like? Yes, it's a subset of what you can do in a SQL. Is it SQL? No.
Well, this is the biggest problem. I mean, someone did actually contribute a SQL engine for Infinispan, and there were so many limitations to it. Oh, you can't do this kind of clause, you can't do that kind of clause. It was like, you know what? It's actually not that useful at the end of the day. You can only do the most trivial things, and then what's the point? And it's not that the implementation was bad. It's not that the guy was a bad developer who did it. I mean, there is a logical mismatch between those models. SQL is designed to run in a single server. It's not designed to run on many servers.
So if you look at the columnar distributed databases like Vertica and other databases, then you do this in the but yeah, they are structured.
And there are limitations as well. You don't have full SQL 92. I mean, it's fine. You have a limited SQL, but then for me, I think that's actually a pointless thing to do. In that case, you may as well move on to a new model. Like I said earlier, the relational model anyway was a hack, and you need to use things like Hibernate and whatever in between. You may as well go to a fully object-oriented model at this point.
So as far as the API design is concerned, are you going to take advantage of all the filter, all those things Lambda is defining?
Well, this is what I mean by querying. I mean, so that bullet point does not actually mean SQL or a SQL-like language. It could mean anything, like you said, like lambdas, filters, closures, to help you filter your data set, to iterate over your entire, And again, how it's implemented, maybe MapReduce, and maybe something, who the hell knows what. That's an implementation detail. But from an API perspective, what does that look like?
Hide the complexities, like whether the data is distributed.
Absolutely. And could do that in parallel. It could be both. It could be, do some stuff on a remote node, some stuff that's happening on disk, and you could do that in parallel as well. So.
This morning, Lambda, you saw that. It's pretty good. It actually addresses a lot of possibilities.
Yes, it does. Which is why I find that very interesting to talk about, because if we're actually going to try and standardize on a way to do this, it should be something that is compatible with the way the JDK is moving as well.
So. Let the JDK
take care of that from the API? Yeah, I mean, that might be enough. That's what, it might well be enough. But is it? This is again where I want to open it up to the floor. What do people think? What do people who are using it think? Is that enough?
That much about data grids, but from the discussion, it seems more or less like, I mean, if you have a large data, you probably go for a MongoDB kind of a stuff where NoSQL database, and if you have few GBs of data, you probably prefer a memory kind of a database because you can do aggregation, MapReduce, and everything on MongoDB as well. I mean, performance-wise, I'm not sure about how performant they are. Is that true?
Just to be clear, data grid, we're not talking about a few gigabytes of data. You can scale data grids to terabytes of data.
By few gigabytes, I mean 100 gigabytes.
Yeah, I mean, you can scale to terabytes quite easily.
You can scale them to hundreds of nodes. The benefit of data grids is the whole scale out, because it allows you to partition, take 100 machines and basically spread it, make them look like one. Think about virtualization the other way around. Right? Instead of splitting one machine into many small boxes, take a bunch of machines and make them look like one big box. Right? And you can have hundreds of cores and do processing in parallel on those hundreds of cores and have very large memory capacity. And then you can do things like take things to flash, right? If you have flash storage, then you can also upload some things to flash. You can upload to disk, right? So it doesn't necessarily have to have everything in memory. It can have significantly large data sets. I've seen some significantly large data sets. On the other hand, you look at something like MongoDB and how scalable it is. right? If all you need is to store a lot of data, but you don't really need a scale, yeah, Mongo is just fine.
But if you shard your data properly and all.
If you shard it, I mean, Mongo,
Well, I mean,
I'm not sure what the latest, I mean, Mongo used to have, I'm not sure if that's still the case, used to have a global write block. So, yeah. So, I mean, there are issues there. And then configuring Mongo, I mean, data grids, all the ones I've seen so far, are very easy to cluster. You just fire up nodes and they cluster. The only thing I've seen in NoSQL space that's similar to that is React.
So, I mean, which one is that?
React.
So my point is that if you have certain system that has a usability, let's not say that Mongo has some problems with lock-on and everything, if you remove those points, just for the usability point of view, would you say that data grid is similar to MongoDB? I mean, data MongoDB?
Yeah, I mean, they're all similar. Right? They all have proprietary APIs at this point, and you know,
well, that's the purpose of the JSR, to try and standardize the APIs to make it look.
Like this JSR, I think it's definitely worthwhile doing it because there's so many different APIs for so many things that they're conceptually very similar. Now, some scale better than the others, some can have more storage than the others. You know, they all have different pros and cons, but having API that kind of captures what the most important points are, and you can use across all those different hosts and different servers, grids, NoSQL databases, it would be very beneficial in my opinion. So the question is what should go in that API?
Absolutely. I mean, and I know that we can't cover everything in a single BOF like this. What I really wanted out of this was to get everyone interested and involved, and join the mailing list, join the discussions, and then continue the conversation as we move forward. Join the adventure, so to speak. You know. I'm sorry, by?
The Lambda story.
The Lambda story, yes, okay, yeah. Yes.
Like Dojo, they added like futures and promises, which is really, really nice.
Yeah.
So if these things can be, sometimes I wish Java has flexibility of JavaScript.
Yeah.
Well, I think
Coming down to this Lambda story here.
Lambdas are a feature that we used to enjoy in Smalltalk. They were called block closures. And if I think they have the potential to relieve some class loading requirements in data grids.
They definitely do. I mean, I've got a Python background as well, and again, there's a lot of cool stuff there that I wished I had in Java for a long time. But we're finally getting there.
Honestly, just looking at it again, the coherence is the one I'm most familiar with. So looking at the coherence API, I can see again lambdas or closures being used for queries. I can see them being used for entry processing. They can be used
for a lot of things,
right?
absolutely.
So if you want to deploy a new entry processor to use the clearances interface, then you don't necessarily need to bounce the server or reload the class or come up with some other fancier class loading scheme like grid games.
Right.
So lambdas would be good for that.
So you mentioned Hibernate.
Mm-hmm.
It's a hack to get an object model against a relational model. But data grids are an object model. So maybe the idea of actually use the JPA query language to access these.
Yes, JPQL is something that I considered for Infinispan specifically, as before this JSR, as the official way to query Infinispan. I stepped away from that because I've actually found JPQL also a little bit too relational.
Well, because it has.
And exactly, because they just translate it to SQL in the end of the day.
But if you work together, I mean, it seems like you should be able to. I don't know if it'd be just obviously it can be universal because relational databases aren't going to.
Yeah.
But I mean, even if you use that as a base, use some of the same structures to try to keep the structures as similar as possible, syntax, just to make it, not obviously directly portable, but not do something completely new that you have.
Yes, as far as possible, you're right. I agree with keeping familiarity, but should we be keeping familiarity with something like JPQL, which still has a lot of, which tried to keep familiarity with SQL, and that chain kind of goes backwards, or do we want to have familiarity with something new that's going into the JDK, like for example Lambda structures, which actually may be better suited for something like this anyway? right? I mean, this is where the discussion is open, really, and this is why I want to invite everyone to the mailing list and talk about it.
You get better pickup for it if it's more back, if it's more similar to things that are already exist or more.
Lambdas are so simple. All you're saying, you're expressing your criteria in
Similar
Java,
not, that's not.
right? You can express your criteria in Java. The same criteria you would put in your if statement. You can specify it in the Lambda and send it into the grid to execute. Right?
But the problem is getting uptake from people who've been writing.
People who've been writing SQL for 20 years, I know, yeah.
If we're going to say
This is for Java programmers. I mean, it's Java API. For a Java developer, I find personally Java code much easier to write.
Yeah.
Debug and get
I want you guys to contribute those use cases. Again, it is a very new JSR, so start. Not a lot yet. So far, it's just vendors, and I want to get more users involved.
Because if you are trying to make this a better rules for the SQL can try to use that, then that makes the life harder for the Java programmer. Let's say, for some reason, let's say you're keeping all the stock-related data in your data grid. Let's say if your analysts are coming in and then they want to get the data, then you're not going to keep creating reports in your Java programming. It's going to take time. If someone else is coming in, if they know some kind of querying language, then it's much easier for them to do the things, because that's how the life is going to be, whether we like it or not. Because moving forward, the applications, what we will be applying on top of these things will be like entirely different than what we have seen today.
Sure, yeah. And if you're doing something new, I mean, you're writing something new from scratch, so you don't have to follow old patterns, do you? I don't know. I mean, like I said, that's open
It's
to.
not about the old pattern, right? It's about the old usage. The usage, if you look at it, the usages are going to move. The old usages are going to move towards something which is new.
Mhm.
But the usages are going to stay similar. And the people who are moving from different things to the newer thing, they think, okay, this is going to be much better. If I get this thing, it will definitely solve certain of a problem.
No. Anyway, we're just about out of time. We're actually a few minutes late. So I'm going to leave you guys with some URLs to actually join the spec. The second one, that's the wiki, which has all the information in 347, including the mailing list, the Google group. Who's been involved with JSRs here before? Any hands? Okay. I don't know which JSRs you've been involved in, but the way I'm running this is a little bit different from most of the other JSRs. I'm not putting any strict requirements on having to be a part of the JCP and all that. I'm an open source guy. I'm kind of running this in a very similar style, where the entire thing happens in the open on a Google group. Anybody and everybody is allowed to participate. It's an open group, and I really want to hear the stories, the ideas from not just vendors but users as well. So yeah, please do join. Right. With that, well, thank you for listening, and I won't keep you from your beer any longer.